Good morning everyone, I'm Vaibhavi. Today we are going to learn about the structure of an atom. Intriguing, isn't it? Because atom is literally the basis of everything and it is so microscopic in nature that we need advanced techniques like scanning electron microscopy to visualize it. Now we understand that it is so microscopic. But due to technology, we have been able to decipher the structure of this atom. But it's kind of complex. And for our understanding, for our day-to-day problem solving, we cannot rely on those images. So what we study or what we see in books is a very simpler representation of the atom. It is called the Bohr model of atom. So what did Bohr say? What does an atom look like? Though the Bohr model is the latest accepted atomic model, previously it was basically the first atomic model was given by Thomson, which was later improvised by Rutherford, and finally all the drawbacks of the Rutherford's model and the Thomson's model was rectified in the Bohr's model. So Bohr said, in an atom, please try to visualize it, there is a core. Now this core, it consists of particles. What kind of particles? Are they charged, uncharged, and what is this core exactly? So this core we're talking about is actually the nucleus. It is the center or the core of the atom. So the nucleus contains two types of particles. One is neutrons and the other is protons. Neutrons is neutral. They have no charge. But protons, they have a charge. What kind of charge? They are positively charged particles. So there is an atom and in the core there is nucleus. In the nucleus there are two types of particles. One is neutrons and the other is protons. Now after this is about the core. In the next stage we come across electrons. So these electrons are orbiting the nucleus in various shells. Literally saying, electrons are like the heart of it, because all the organic reactions we study the movement of electrons from one substrate to the other substrate. All the reactions are governed by these tiny particles. So now these electrons, they are in shells and they are negatively charged. So as we know, in nature, the positively charged particles attract the negatively charged particles. And this is called a nuclear force. The protons exert a nuclear force on the electrons and they try to pull them towards themselves. So this is called as the effective nuclear charge. But the farther the electrons are in the atom, there are various shells where the electrons are rotating or revolving around the nucleus in their orbits. There are various orbits like that. So the farther the orbits are, the lesser is the effective nuclear charge. Now, in the 118 elements of the periodic table, every element has its atomic structure. First, there is the simplest atom or the first element of the periodic table is hydrogen. It has only one electron, one proton. It has no neutrons. The next element is helium. Now helium has two protons. So if the element is neutral, that is, it does not have an overall positive or negative charge on it, then the number of protons equals the number of electrons. So when we say helium, we said helium has two protons. So it means helium has 2 electrons. So in the first shell, called the K shell of helium, there are 2 electrons. Now the question is, can this K shell, the closest shell, the first shell near the nucleus, can it have more than 2 electrons? No. The answer is no. It cannot have more than 2 electrons. Now, how do we decide how many electrons can a shell hold? Now, this is actually on a formula called 2n square, where n is the principal principal quantum number. Now, quantum number and how is it and what does it do, it's for a later class. But so when we say the first shell, we say the n, it's 2n square formula, in that n is equal to 1. For the next shell, K, L shell is the second shell, so n equals 2. So when you put it in the formula for, let's say, the K shell, we know n equals 1. So 2 into 1 squared, that is 2. So K shell can have maximum of 2 electrons. Now let's talk about the L shell. In L shell, n is equal to 2. So 2 into 2 squared, that is 8. So the L shell can have a maximum of 8 electrons and not more than that. So this is a rule which cannot be violated. So this is about the general understanding or the basic understanding of an atomic structure. Now there are more concepts, there are more rules of electron filling, the nature of electrons and quantum numbers, but that is a whole new topic for the next class. So meet you there. Thank you.